Good morning, dear student. In last lecture, we will discuss about the subject as a DA, that means algorithm design and analysis, and we have discussed many points about the this subject, just like because just like why we are study this subject and. What is the objective of this subject, like why we are study the DA, and what is the objective of your subject DA, and I hope we have also discussed about the course outcomes, that means after studying the DA, what is the benefits about the student and all things. And after that we was discuss what is algorithm and why we are writing algorithm, and definition of algorithm, and we will discuss the property of the algorithm, and we have also example to write a algorithm, and some characteristic of algorithm is also discussed in last lecture. And what about the pseudocode, I was discussed in last lecture, and some basic issues related algorithm is also discussed in last lecture. And some problem solving technique, that means before writing the algorithm, some problem technique, and these issues are also we was discussed. And after that we was I hope we discussed the step of writing an algorithm, and some steps are also discussed at last lecture, and how to write a proper algorithm using step by step procedure, and discuss about the algorithm and program, and that means some basic difference between the algorithm and program. These points are discussed in last lecture, that means we have started today from algorithm design method. So in a algorithm designing methods, we are discussing many methods, and many platform methods. So we will start here designing methods of an algorithm. Okay, so today we are discussing about the algorithm designing methods, and we are brief discuss in here. So today we will discuss from here what is the algorithms methods. Okay, so we will discuss this methods as a brief, and after that in whole course of DA, we have discussed divide and conquer, branch and bound, backtracking methods, dynamic programming, and all these methods are discussed further in next modules. So here we will discuss theoretically and understand about the this type of method though. So we will start first method. This is called divide and conquer method. That is the name this method, divide and conquer. Okay, so in this method, first of all we have to divide your problem in sub problem. That means if problem is large or complex, then we have to divide this problem in sub problem. Okay, and after that solve every sub problem, okay, individually. ठीक है ना? So why we have to divide? Because of that, if problem is large or complex, then we have to divide. Okay, and solve every problem individual as a recursively. That means we have to solve all the problems, okay, but individually. And then how to find the solution, and then we have to find the solution of this problem to combining the all sub problems into a single solution problem. The and whole original problem is generated here. That means this is main approach about the divide and conquer. That means it is based on the divide problem into sub problem, and divide problem into sub problems. Sub problem must be as the same type. That means we have not changed about the type of the problem, and do not need to overlap. That means one problem is overlapping on the second problem, second sub problem, and then solve each sub problem recursively, and then combine the solution in the original problem solution. We contain two or more calls, and we have discussed in next to next lecture shorting, and we will see on shorting problem, and quick short and binary search techniques, how to apply this divide and conquer method. And another like one take we will one example like just a quick short. Okay, so what about we are briefly discuss in next lectures uh, how to work this quick shot on the divide and conquer method. Just we have to discuss verbally and theoretically. We have partition, and that means we have to short a array. That means we have to partition your array into parts. Okay, around a given around taken a pivot number. That means here we have to take a pivot number, and according to pivot number we have to divide our problem in a sub problem. Okay, and then recursively quick sort each part of an array, and after that we have to connected all the sub problem and finding the solution. Okay, this is simple procedure to apply divide and conquer method. Okay, so next approach is dynamic programming method. Okay, this is called dynamic programming method. It's similar, we have to say it's similar to divide and conquer, but sub problem must be overlap here. Okay, we are discussing this technique in future through the examples and another topics. Okay, so in we have to say dynamic programming is a technique for efficiently computing recursions by shorting partial results. Okay, and it is method to solve the problem exhibiting the properties of overlapping of sub problem and optimal substructure that takes much less time than the Navy method. Okay, so after that we have goes as a divide and conquer. That means we divide our problem in a sub problem, but here goes for as a sub problem as a overlap. It is based on remembering part of result. That means we have to and at the dynamic programming approach we have to say divide problem in a sub problem. That means we have to divide our sub problem. That means we have to take a a small problem, and these sub problems same as a same type, but here must be overlap, and solve each sub problem recursively and store in the single solution, and combine this solution and find the original our solution. We have taken an example like a Fibonacci series. Okay, so I hope everybody know what Fibonacci number and what is the Fibonacci. I hope you all know about the Fibonacci number, and that means we have to say Fibonacci number 1 1 0 1 1 2 uh, plus 1. That means we have to say how to this dynamic programming. This is given example. That means Fibonacci series function is as a recursive, and to see that first value is 1, second value is 1, and then and, next is finding the before two's values. So we have to say the Fibonacci number n minus 1 and plus n minus 2. That means 1 1, and then next is 2. That means 1 plus 1, this is 2, and the next number is this is equal to 3, and next number is 3 plus 2, this is equal to 5. This is Fibonacci function, and this is we have to recursive algorithm to calculate the Fibonacci number. We have to say n is start with the 0 or 1 and return the value 1, and else computing this function. That means we have apply this function Fibonacci n minus 1 and Fibonacci n minus 2 and return the sum out value. And this is recursive to use finding the Fibonacci number. But if we have applied dynamic programming, then what we have to say? That means we have to say if number is start with a 0 or 1 and return the 1, that means we have to first return these values, okay, and else solve the value of n minus 1 and minus 1. Look up the value if previous compute, okay, and else recursive compute and find the sum and store these values. That means we have to overlap function here. That means we have to store again, and last one is finding the sum of values, okay. So this is the one example according to dynamic programming. Next we have to discuss about the backtracking method, okay. In backtracking method, everybody play the game of maze problem, okay. I hope so. In a backtracking, that means we have finding the we have finding our solution. We have backtrack the path. That means backtracking algorithm try to possible possible until they find the right one, okay. In DFS search, that means we have to say DFS. I hope you know. In data we will discuss it is DFA and depth first search of the set of possible during the search. If the alternative does not, then search the we will backtrack the path and choose the next path, okay, and finding the solution. So we have to say consider a search every possible combination in the order of to the optimization. And what is the approach? We make any possible moves, and if solution return it, else backtrack your path and select another move and select your another path and finding the next solution. If it moves remain failure, then return. Otherwise we have to finding and what is the example about this? This is n queen problem and maze problem. N queen problem is newly for student which discuss the first time, and which but maze problem is I hope you have to play like a maze problem, finding your path. That means we have to start and go silly path and go for result and finalize and finish the value. This is the backtracking method about the, and then here finding the path is and start from the beginning of the maze, and uh, uh, if exit, then return the value is true, else each step from current location, okay, and recursively find the path, return with the first successful step, and returns fails if step is failed, okay. This is backtracking method. And next method we will discuss about the greedy approach. The word greedy is says that greedy algorithm or greedy approach, we have to say seek to optimize a function by making choice. That means greedy creation, which are the best locally, but not do not look at the global problem, okay. The result is the result is good solution, but not necessarily best of one, okay. The greedy algorithm does not always guaranteed it is does not guaranteed it is a optimal solution. However, it is generally a process to finding the solution that is very close to the value of optimal. We have not say this solution is best solution. We have to say it is nearer to optimal. ठीक है ना? That means it is based on the best current low choice. It approach is at each step the algorithm choose best local solution, avoid here backtracking. Okay, we have to discuss some examples. Minimum spanning tree algorithm, crucial and press, Dijkstra's sort path, Halfman code, and all these. Okay, so this type of examples we have discussed in further videos. So here we will discuss only theoretically what is this. And next method is brute force method. We have to say it is trying to all possible solution for finding or solution of any given problem. And what is approach about the brute force? We have to say generally evaluate possible solution until satisfactory is not found. Okay, and best is found here. Okay, and all possible solution found, return the best solution, return the failure if it is not satisfied solution. Generally the most expensive approach, because of that, to finding best. And if we are finding any best solution, then we our goal the best. And maximum, if we are not satisfied the solution, then failure is the expensive approach to solve the uh, to solve the brute force problem, according to brute force problem. And we will discuss next method in a algorithm design technique is called the branch and method. So what is bound method? Here we will see here, based on the limitation search using current solution. That means branch and bound algorithm, a given problem which cannot be bounded, divide into at least two new restricted subproblem. Okay, the branch and bound algorithm are method for we have to say global optimization in non-conventional problem. Okay, and we have also say the branch and bound method can slow as a process, and however it is worst case they required effort of the grow like exponential series with the example of, with the given problem of the site. That means we if we are goes as a branch and bound method to solve any problem, then our process is slow. And if your process is slow, that means complexity is huge, and time taken by the your problem is huge. So we will find the worst case condition is here, because of that in a traveling cells problem, take an example like a traveling cells problem. That means a salesman travel to different cities at once and return to our city. This is the method of this is procedure to traveling cells problem. We have to solve two types, dynamic approach also, and divide branch and bound method. Yeah, when we will discuss traveling cells problem and bound method, we will see it is huge time taking process. Okay, so in this branch and bound approach, track best current solution found, eliminate the partial solution. That means eliminate all the partial solution and finding on one best solution, and reduce the amount of backtracking. So it's time taking, and worst solution is find here best solution. That means finding best solution, but as a worst time taken. Okay, and then next and last method here we will discuss heuristic method. This method is not covered in this da video lectures, but this is also a method So we will try to understand what is the heuristic approach. It is based on trying to guide search of the solution. Heuristic, that means we say the rule of thumb. Okay, and approach about the heuristic, it is generate evaluate possible solution using thumb, stop if it is suggested a solution and can be reduced some complexity. This is this is the algorithm technique, some technique which we have to discussed here, and many other techniques is also just like is algorithm technique and all these. We will discuss some here and some in next video lectures and all other lectures discuss. So here we discuss about the analysis of is the analysis algorithm. Okay, so uh, before analyzing an algorithm, we will discuss one point: how good is algorithm. That means how we will say your algorithm is good, it is correct, it is time less time consuming, and all these things. That's what we have to say. Okay, so we will discuss analysis of algorithm. So my first point is here, how good is algorithm. That means if if we have to say this algorithm is good, that means we have to say it's time efficient. Okay, this is time efficient, that means time taken by this algorithm is less. Okay, this is space efficient, that means space space complexity of this algorithm is less. And one thing is that the correctness of algorithm, that means it is correct to find here, which we have to write an algorithm. And the second major point is here, in analysis of algorithm, does there exist a better algorithm. That means your algorithm is better, which is existed here. Okay, so we have to discuss about 2 points. There is lower bound, that means lower bound that sorry lower bound, that means we have to say uh, uh, lower bound, that is we have to say one thing: does the complexity of your algorithm is lower. Okay, so we will discuss lower bound. And next point is optimality. That means we have to say your algorithm is optimal or not. Okay, these points are discussed in the analysis of algorithm. So some another points of algorithm analysis, that means according to this, the main affecting on the running time of an algorithm. If we have to say our of algorithm or program, that is we have to say this program or we have to discuss algorithm. So we have to say our algorithm is taken 10. Okay, then what type of other effects is affecting your algorithm, so we will here discuss. That means we have many criteria to the running time of an algorithm. That means including first of all, everybody know about the CPU, central processing unit. If CPU, your CPU is as a latest hardware and latest peripheral devices is here, that means your processor is good, then the speed is enhanced here. Okay, and designing thing time. Okay, that means what type of designing here to develop in algorithm, and programming time and debugging time. And that is these are criteria to affecting your running time of an algorithm. And language used, that means what type of language you have to work here there. So and coding efficiency of your program, what is the coding efficiency of this your program. Sometimes we have to write a program. If I ask you, write a program about the add of two numbers. Then after some time I have to say write a program for separation of two numbers, and after that after some time we have asked write a program for multiplication of two numbers. And last one question, to develop a to develop a a simple calculator which is calculate plus sign, negative sign, multiplication and division. Then what to do if you are writing your programs in a efficient way, like using the function, then we have to then you use these function in this program. If we, otherwise you have write again and again, then this, you have to write your code like efficient, okay. And the quality of input, that means good, average, better. We will discuss these points: good, bad, average, okay. That means best, average and worst cases in your algorithm analysis. And some another points: the problem divide to the problem divide from two algorithms for solving the same problem should both here. That means what is the machine independent, what is about the language independent, what is about the environment independent, loading on the machine or system, and or another thing, realistic phase time discuss at the algorithm analysis, and the mathematical study and all other things, okay. So after the analyzing these algorithm, find your efficiency of an algorithm, okay. How to find the efficiency of an algorithm? On the algorithm based, we discuss about two type of efficiency in algorithm. One thing is that what time will take your algorithm to execute, and second point is that what space, what consumed by your algorithm in your system. That means next point is algorithm efficiency. Then efficiency of algorithm we majorly discuss about time, about the space. The efficiency of algorithm is usually measured by the CPU time and space. uh, the time is measured by the counting of number of key operation, how much does take the run algorithm, time, total time take to execute an algorithm, okay. So we will discuss here two factor about the algorithm efficiency. That means time, and one is space. That means space is measured like counting the maximum memory is consumed by your algorithm or program to be completely run. Okay, to be completely run. So these are the two points to affect the algorithm. That means we have to check the performance analysis of algorithm according to these points. So how to performance analysis and algorithm, performance about algorithm is tackled by the 2 points. One is the space complexity, and second one time complexity. So we will discuss what is the space complexity and what is the time complexity. In one line we have to say the total memory consumed by your program in of your algorithm to be execute to be time of execution, that is called a space complexity, okay. And we have also say that the amount of memory need by the program at the run to be complete. And components of space complexity, that means what consumed by the instruction, and what space consumed by the data space, the space need the like your variables, constant, dynamically allocated memory at of runtime, and involved stack space, that means information needed to resume execution of partial complete. That is example the return the value of local and the formal parameters. These type of points have to discuss in the space complexity. But one thing in your mind, what is the space complexity? The total amount of memory to be by a program to be run time. Okay, now at the completion of run. Okay, this is the space complexity. Okay, so this is the point. This is the point about the space complexity. And next complexity is like a time complexity. We will discuss here that the time complexity, that means the total amount of time which is at the run time completion, your program is run and done your result. Total time is taken by this program is called time complexity. That means we have to say the running time of a program as a function of the size of input. Okay, the amount of time program need to run to complete, this is time complexity. And time complexity varies from the system to system. Sometime we have to, because of that, if your peripheral devices is not very fast and latest, then sometime we have yeah, same program run different system, taken the time as a different. This is two way to calculate your time complexity. Someone is some sorry some complexity is count by the operational count, and some is step count is also here. We will discuss one example how to find your time complexity and how to find your space complexity. We need to discuss first we need to discuss here we need to we discuss the time complexity, but not as a space complexity. Then I am discussing here first how to count the space complexity. Okay, how to count. Here we have first I will tell you here the complexity count, not a any parameter like time is seconds or minutes, and space is here byte and something. Here just like a count as a number. Okay, so here we will discuss the space complexity. So first this point, this function, uh, sorry, we have to say we using this is the given function. What is the function? The sum of write a function sum. And this how to calculate space complexities. First this is assigning the value. Then we have to say this is one as a first time, one time assigning, and one time we have to discuss. Okay, so this is one, and this is the for loop. Okay, and this one is for loop. uh, for loop start with the 1 to n. That means at what time this for loop is terminated. He is starting with the 1, then plus 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, 1. Then again one time, one time, one time, one time, one time. That means if I is equal to 1, this is 1, then 2, then 3, then 4. Then execution is 1 plus 1 plus 1 plus. And at what time? This is end time. Then we will say, 1 minute, it is. Then we will say after what time this for loop is terminating from here. Okay, so we have to say end time to be execute, and for termination of the for loop at the n plus 1th time. Okay, this for loop is terminating from, that means this is consuming space n plus 1 time. Okay, and this is a function which is running in the for loop. He is also reflecting one time as a sum of numbers. So this is also taken one space time, and then we have to add it. So we will find n plus 3, because of 1 plus 2 plus 1, this is 3, this is n. So we have to say this function as it space complexity, this is called n plus 3. Okay, this is the space complexity. And next one is we have to discuss the time complexity. So time complexity for this this is this point is one time take. Because of that, if function of sum is called, then initialization of the number s equal to 0, this is 1. Okay, the for loop is terminated after plus 1 step. This is here write the n plus 1, and this is the part of loop. Then this is calling itself is n time in internally, then we take time, this is n. Okay, and then return the value by s, this is one time he will return the answer. So we have to say total time taken by this is 1 plus n plus 1 plus n plus 1, this is called 2n plus 3. This is the method to be count your time complexity. That you have to also another type another procedure is also followed. So this is the example, and one example I will take also, this one. This is here we have to call. Okay, what he done, this is sum, and here we have to use nested loop. Okay, and we will also another examples about the nested loop and single loop. So here then this is nested loop, then what he count. So how to count here time complexity? First, this is for loop, outer for loop. This is and at what time he will terminate. Then we have to say he is terminated, he goes for 1 to n time, and he will terminate at one step extra, then n plus 1. So we have to say this is n plus 1 time, and this is inner loop. Inner loop is also itself terminate n plus 1 time, this part. And what is n here, extra n here, that is due to this loop, due to outer loop, this is n time run. Okay, so we have to say n into n plus 1. Okay, clear, it is clear. And this is count, then count is I of j, this is n into n. Okay, so we have to adding these values, then we have to say n plus 1, and here n into n plus 1, this is called say n square plus n, and this is n square. Okay, and this total function count here, this is 2 times 2 n square, this is 2 n square plus 2 times n, this is 2n plus 1. And we will discuss in next video how to find this steps and into n. This is total step. And if we have to discuss properly time complexity, then what is the time complexity? The time complexity is here O n square. What is the O of n square? In next video we have discussed to we calculate the time complexity, and some another method that is called recursively how to find your time complexity and another things. So thank you for watching this video. We will discuss in next lecture how to calculate